There are three properties we can use to expand or simplify logarithms. The first property is called the product of logarithms property. You'll notice that when we take a log of a product, m times n, we can expand this by rewriting it as two logs, log of m plus log of n. So product is going to correspond with an addition. Then we have the quotient of logarithms property. So again, we have one log of a quotient, m divided by n. We can rewrite this as two logs, log base b of m minus log base b of n. So we're looking for a minus sign when it's a quotient. And the final one is the power of logarithms property. So we have a log of a variable or a number to a power. And the way we can simplify this is we actually write the power times the log of m. So we're looking for a number in front of the logarithm, and that's the power of logarithms property. So let's take a look at some examples. How would we expand the first one, log of m to the third? Now this doesn't have a base, so we're assuming this is base 10. So this is an exponent, a power. So we're just going to rewrite the 3 in front. So 3 times log of m. Number 2, we've got two things going on here. We have a product, m times n, but then n also has a power. But since n is the only one who has the power, we're going to deal with the product first. So I'm going to rewrite this. Product means I have to add, so I'm breaking it into two logarithms that are added together. So I have log of m plus log of n squared. So log base 10 of m is completely simplified, but log base 10 of n squared can still be expanded more. So I'm going to rewrite this again as log m plus, I'm going to put my power out front, 2 log n. So this would be my completely expanded form. Number 3, I'm looking here and I see a quotient. So I'm going to rewrite as a subtraction of two logs, the top numbers on the top, on the first to come. Okay, so we have log 1 minus log n squared. Once again, we have a power, so I'm going to rewrite this again. Log of 1 minus 2, that power is going to go in the front, log of n. Now, I'm seeing that this part actually has a number. Can we solve it? If we can solve it, we're going to solve it. So remember thinking 10 to what power is 1? So anything to the 0 power is going to give us 1. So this is actually 0. So again, I'm going to simplify it even further as negative 2 log n. That's my final expanded and simplified form. Number 4, I've got a product, and I can think of my square root as a power. So let's deal with the product first. We're going to rewrite it as addition. Log base 10 of m plus log base 10 of the square root of n. But we know the square root of n is really n to the 1/2 power. So I'm going to rewrite this as log m plus 1/2 log n. And I have it completely expanded out. So those are pretty easy. You just have to think about if you have more than one way to expand it, like you have a product and a power, do the product first, as long as the power only has power over one of the variables. Okay, now let's go backwards. We're going to start with an expanded form, and we're going to condense it back down into one single logarithm. So we're going to go in order. So we have the natural log of 16 plus 2 natural log of 5 minus natural log of 4. Since addition comes first, I want to make this turn into a product. I also have a power here, so that 2 is going to become 5 squared. So I'm going to start off as ln 16 times 5 squared minus ln 4. Now I have a difference, so I'm going to do a quotient rule. So this is ln 16 times 5 squared over 4. And then I'm going to simplify this as much as I can. 16 divided by 4 is 4. And 5 squared is 25. So it's ln of 4 times 25, which is ln of 100. And I really don't know off the top of my head e to what power equals 100. So I'm going to keep it as ln of 100.
Mom.
Just a minute, baby. Okay, let me finish this. Number 2. We have a sum, so we're going to have a product. So log base 4 of 7 times 5 is log base 4 of 35. And again, 4 to what power is 35? I don't know, so we're going to leave it as is. If it was something simple, we could simplify it. Otherwise, we'll just keep it as is. Number 7, we have a sum and a difference, and we have some exponents because we have some coefficients in front of the logs. Okay, so let's start with the sum. We have ln 2 to the 3rd power times 49, or the square root of 49. It was 49 to the 1/2 power, minus ln of 14. So if I simplify this as much as possible, I have ln 8 times 9. No, I'm sorry, 7. Minus ln 14. So we have ln 56 divided by 14. And we can simplify that. So ln of 4. ln of 4. Okay, the last one we have. Okay, this time we start with a difference, and then we have a product. And I see some exponents. So let's start with that difference first. Log base 6 t to the 4th over y to the 8th power plus 5 log 6 to the v. So again, we also have another power there. So then we're going to have log base 6 t to the 4th divided by y to the 8th times v to the 5th. And we could say that this is log base 6 of t to the 4th v to the 5th over y to the 5th.